Hello, I'm Matt Horns. Here we are at the west channels of the Malibu Lagoon. This is the work site of the Malibu Lagoon Restoration and Enhancement project set to begin June 1st, 2012. I have worked throughout this watershed and throughout this lagoon in aquatic habitat assessments. And that's my field of expertise, aquatic habitats. I've done extensive graduate work in geology and in watershed management. I've worked in watershed restoration for 30 years, 33 years now. Since 1979, I've done extensive data collection throughout the Santa Monica Mountains, focusing on Malibu Creek watershed, and I've collected a lot of data and done a lot of analyses throughout the watershed, including the lagoon here, where I've conducted fish surveys and circulation studies and dissolved oxygen studies. There's many issues involved with this project, and my expertise, as I say, is aquatic habitats. That's what we'll be discussing today. Now, when we look across our view here, we can see some islands and some channels. All these islands are remnants of compacted landfill that was placed in the former lagoon area in the 1920s, starting around the 1920s. This has a long history of being athletic fields, being garbage dumps, and before that it was part of the estuary, and it supported thriving populations of shorebirds and aquatic species, including steelhead trout, tidewater goby, and a lot of other fish. So this is the site, as I say, of the restoration project, which is designed to restore this back to natural estuary conditions. Now, as you look across here, you see there's not much aquatic habitat. Most of the former estuary is still filled in with compacted landfill. There was a restoration project done here in 1983 that made somewhat of an attempt to restore the estuary habitats here. And again, we're staying focused on aquatic habitats here. There's a whole bunch of issues involved, each of which we could talk for about a week. So I'd like to stay focused on aquatic habitats here in the West Channels and how they relate to aquatic habitats in the main channel, which will not be touched by the restoration project. It's fine the way it is now. Okay, let's go around the edge of the lagoon. Just beyond these bushes is what we call a dead pool. It's a place where the bottom substrate is devoid of oxygen and the aquatic ecology is pretty much dead. Okay, now we're right here on the map. We're continuing south on the trail towards the beach. At this point, after the project is complete, there will be a viewing station here that gives visitors a panoramic view of what will be an absolutely beautiful open lagoon full of thriving birds. What we see now is islands, artificial islands, underlain by compacted landfill, and basically no birds. It's going to be much different after this project here is complete. What we're looking at here is compacted landfill with narrow channels that were dug by bulldozers into the landfill that were meant to create aquatic habitat, but failed to. As you see, there's almost no birds here, almost no wading shorebirds. In a real estuary habitat, this area at low tide would be teeming with shorebirds, feeding on the abundant life that lives in the mud flats that are exposed at low tide. We're looking here at a gauging staff, and this is used to record this water level. And the numbers on the staff refer to the elevation. It has instruments in it that continually record water chemistry parameters, including pH, dissolved oxygen, conductivity, temperature, and some other physical water parameters. Periodically, someone comes here and collects samples from this well, and they take them to the lab and analyze them for nutrients and bacteria. And a concern here is that the lagoon is that way. There's some septic systems with their leach fields that way, and sometimes the groundwater moves from the areas of the septics underground here into the lagoon. And so that's what this well is here. There's a whole series of these wells along the perimeter of the lagoon that are monitoring the groundwater that's going into the west part of the lagoon. Right here we have an area that's chronically infested with euphorbia, a very severely invasive non-native plant. And it's this yellowish, greenish plants that are growing among the taller native plants. And this, I was with a volunteer crew that removed all of it 6 years ago, and as you see, it's come back. So we need another volunteer crew in here to come in and help out. So all around Malibu Lagoon, we always have opportunities for volunteers to come and help our lagoon stay healthy and become even healthier. Looking at these low bluffs along the edge of the water, those are the edge of the compacted landfill. And they've been eroded into steep bluffs by high flows on Malibu Creek during intense winter storms. Those have been slowly eroding into the compacted landfill that formerly continued farther to the right of what we're looking at. Farther to the left, the high flows will never erode that landfill out in human history. So that's why the project is working over there to remove that compacted landfill. It's filling in what formerly was an estuary habit with tidal flows and wide open channels that supported a multitude of shorebirds all year long and provided great habitat for shorebirds. It no longer does anymore. If you'll notice, you see almost zero birds in that area. Okay, now to the right, we see a whole bunch of birds. That area will not be touched by this restoration project. That is beautiful, healthy estuary habitat. And as you see, the birds love it. There's a small fence along here. This fence is marking out an area that's dedicated to snowy plovers so they can roost and nest on the beach right here on the beach sand without being disturbed. This is a species that's very endangered. The snowy plovers, they nest by just finding a little depression in the sand. The Lagoon Restoration Project will not touch this spot. It will be over there. It will not impact snowy plover habitat. In case you were wondering what this thing is I've been lugging around, this is a dissolved oxygen meter. It's made by the company YSI, and it's a model 55A. This is a type of meter that's very commonly used in water quality investigations where very accurate readings of dissolved oxygen are required. Okay, so we're using this instrument today to look at the dissolved oxygen levels in these channels. This is the first bridge, the closest one to the ocean. This trail crosses 3 bridges across 3 different narrow channels. And again, being narrow channels, they constrict the circulation of the water. Pretty much the largest problem from a wildlife habitat perspective in the West Channels that the Lagoon Restoration Project is aimed at is increasing dissolved oxygen levels, because the situation now is that organic matter accumulates at the bottom. Bacteria that decompose that organic matter consume the oxygen, and so I need water deep enough to completely submerge the probes. Dissolved oxygen is what allows aquatic animals to breathe. They breathe the water, the oxygen out of the water, just as we do breathe the oxygen out of our air that we breathe. Most aquatic species need dissolved oxygen at about 50% saturation or greater. Below around 10% saturation, almost nothing can survive. It appears to be stabilized right now at 12.5% dissolved oxygen. So that means that this has 12% of the amount of oxygen that water at this temperature and this salinity and this elevation can possibly contain during like normal situations. When we're examining the dissolved oxygen level at the bottom of the channel, there's several things that influence these. One is the wind, and the wind over a large swath of water can create both ripples that create turbulence in the water, and they also drive the water with the wind, and that circulates water through the water body. It goes with the wind at the top, and then it goes against the wind below. Circulation is also influenced by tidal flushing, and this is a narrow channel. The tidal flushing is minimal. The final plan will, instead of 3 small channels, we'll have 1 large channel about 60 feet wide. That will allow greater volumes of water flowing at greater velocities up and down the channel with the tides. So we'll have better opportunities to scour out the anoxic mud that's accumulated on the bottom. This channel has, at low tide, has virtually no water and no circulation. That's a problem. And we're going to investigate dissolved oxygen levels here in this channel. The dissolved oxygen is quite low here, below 8%. And it takes a while to equalize at the true value, at the true dissolved oxygen levels, above about 75% saturation in the substrate, where in a healthy lagoon we would have a lot of clams and worms and mussels and snails living in that substrate, and those provide food for various fish and birds, and they need oxygen to live. When we're looking at here, looks like we've stabilized at 1. Well, now is it still going down? It looks like it's pretty stable now at 1.4% saturation. That is, essentially 0 dissolved oxygen. Here we are at the 3rd channel going north, the northernmost of the 3 channels, closest to the parking lot. And again, a constricted channel, restricted circulation, and chronic problems with low dissolved oxygen that is being addressed by the Lagoon Restoration and Enhancement Project. And so we're measuring the dissolved oxygen here again. Okay, it measures here at 2.2% saturation. Now we're at the main lagoon channel. This is the part of the channel that is outside the project area. This area will not be altered by the Lagoon Restoration Project. This area has beautiful aquatic habitat. Let's check out the dissolved oxygen levels here. Again, you want above 75%. Higher is good. Good dissolved oxygen levels mean good, diverse invertebrates living in the substrate, meaning there's a good food source for the birds, and as a result, we have a flourishing population of seabirds and shorebirds here. Over here we have pelicans on the island, cormorants on the log, a bunch of ducks floating around. We saw some terns flying over earlier. We have a beautiful, diverse fauna of bird life here because of dissolved oxygen levels are good.